All right, so some upcoming events as we look at, we'll continue naming some compounds. Tomorrow you have a paper assigned to you, but it's just junior high that's gone tomorrow, correct, for track? Okay. What time do you leave? Chances are morning. Okay. All right. Right. I won't be here on Friday either. I'll be returning from Brookings. I don't know if we'll probably still be up there at this time, but regardless, yes, that paper will be signed tomorrow, and as we can see, is due on the 7th. So when is that? It's not Wednesday. No, then it would be the 9th. It'd be Tuesday. Okay. So with that, I'm willing to bet that since you've been sitting in here a couple days now, you're looking at this and remember, okay, a lot of this looks familiar from physical science. Maybe yes, maybe no. All right. So with that, there's one compound up there that is unlike any of the other. Let's see, 1, 2, 3, 4, 5. There's one that's not like the other 4. Okay, so with that, okay, it is the orange because that's which organic family? It's an alkene. Okay, the rest of them are all alkanes. All right. So with that, go ahead and pick a color. Okay. Correct. Okay. So we said brown. So I want to make sure I pick a color that's not up there. Looks like it's this one. Okay. So in naming these, the very first thing you need to do is what? Okay. So what is it? Brown was selected. So is there anything branching off of that? Okay. So does it go left to right, right to left, up into the right, or up and to the left? Sure? Okay, that's fine. So with that, your parent chain we would establish is what? Nonane. Okay? So what is branching off of that nonane? Okay? So what carbon is that propyl group breaking off? Okay? All right. That is correct. So when we reverse engineer this, is what we're going through with physical science as well. We would have done the same thing. This tells you the organic family, which it's a what? Okay? What does that tell you? That there's 9 carbons in the parent chain. What does this tell you? On the 4th carbon. Okay? So everything's single bonded in here. That's correct. All right? There's 9 carbons in here. There's a propyl group, or C3 what? H. Okay? And then this tells you where it's at. It's on the 4th carbon. Okay? So could you make an isomer of that pretty easily? Yes. Yes, you could. And with that, you could just take 1 carbon off of here and put it up here. Okay? So then this is now off. Okay? So what would your parent chain be now? Okay? So now we've got decane, and we have an ethyl group branching off of the 4th. Okay, so now we would have 4 what? Ethyl. Okay? 4 ethyl So what does it mean to be an isomer then? The same what type of structure? Same molecular formula, but the structure is different. Okay, so we went from nonane to decane and a propyl group to an ethyl group. That's all an isomer is. Okay, so the bigger number that you get, the easier it is to come up with isomers, except if you had to come up with all of them. We don't want to do that for decane because there's probably probably 50 or plus more isomers. Okay, that would be possible. So the lower number that you get, I mean, it's easy. You don't have to come up with so many, but the biggest mistake that people make is putting the same structure down. And it's easy to do. And that will just come with that of experience, okay? Whether it's in music, I was trying to explain that to the freshmen earlier, that you may not get the grade that you want, but does every student in music sit first chair? Doesn't mean that you can't, just means maybe you either got to work a little harder or maybe you need to mature a little more. Does everyone start on the varsity team? No. Doesn't mean you can't, doesn't mean that you won't, okay? Then one way you could look at it is also in any heat of a race in track, okay? There's how, if all lanes are full, okay? How many participants is that? And it's not a team event, it's a, okay? Okay. These tracks have 8 lanes or 6? Okay. So someone's got to come in 8th place, right? Okay. So it doesn't necessarily mean that that person will. Someone's got to be last. That's just a fact of life, correct? I think you would agree with that. Okay. Are you ever going to get a hole in one? Maybe. But doesn't mean that you won't. They occur fairly infrequent. But just a bit of advice I would think is that what's the first thing you do when practicing when you get to a golf meet? What's the first? Yeah, I get it. I get my golf clubs. Yeah, but when you're warming up, okay, after that, then what? Okay, I think it's a misconception that a lot of people who play golf, especially at that level, they always want to start working on these 20-footers. How many 20-foot putts do you think you're going to make in a golf meet? Maybe 3 in your career. Maybe. Where are you do you need to practice the most? These 4-footers like this. You would agree, okay? Hopefully, when you get to be about this type of distance, it's pretty much a given. But a lot of these don't want to practice them. Oh, we want to work on these 15, 20-foot putts. Just like maybe when elementary students, perhaps, go into the gym with a basketball. What's the first thing they want to do? Start shooting the three-pointer. Crank it up. Let's work on them 21-footers rather than these little mid-range 8 to 10 to maybe little 6-footers or even layups. Okay? But that's neither here nor there. If we're struggling with these, our point is, it just might take a little more time. Not everyone's going to understand this at the same rate, at the same time. So if you feel you're falling behind, well, you've got that opportunity. You've got this video as a resource, and you certainly got some friends that you can ask as well. Okay, what color's next? Okay, So the first thing you need to do is, just like with the alkanes, because you already established this is an alkene, okay, so what do we need to do first? Which is what? Okay, so we've got heptene. So even if we didn't go any further, again, here's our organic family. So we've got a double bond someplace, and there's 7 carbons in the parent chain. Okay, so how many numbers do you think are going to be, like last problem, there's only one number. It started off as 4-propyl, then we changed it to 3-ethyl. It was either a 4 or a 3. But how many numbers are we going to write in front of this compound? Nope. Nope. 3. What about the double bond? Need to say where it's at. Okay. Well, we can see where it's at. It's right here. There it is. But you still have to denote where it's at. Okay. So, what is our derivatives branching off of this chain? Okay. So, we have a what and a what? Well, just what are the derivatives? Don't say where they're at. Okay, we got a methyl group and okay, a chloral group. Okay, so we'll just put a C there. All right. So, alphabetizing these. Okay, what comes first? Okay. So again, when you're writing these out, it's always going to take more room than what you think. Okay, so I'm going to start way over here and go with 2 dash what? Don't say chlorine, okay, and don't say chloride, okay, because chloride, that's more so of an application all the way up to this point, okay, because this is not an ion anymore, okay. So we got 2-chloral dash 3 dash methyl. Remember, dashes separate numbers, but how do you separate numbers from one another? Commas, that's right. And so there's 2 of the 3 numbers we needed to account for, and the last one is what? That bond is after which carbon? Okay. Okay. So if we reverse engineer this, okay, must have a glare on the board again. Those pesky glares from time to time. That gets to be a problem. Huh? Well, so now when we reverse engineer this, again, there's a double bond someplace. There's 7 carbons in this compound. 1, 2, 3, 4, 5, 6, 7. Okay? So there's nothing written after this 3. So that is designating what for this? It's telling you where what is located. The double bond. Okay? Now, sometimes you don't have to write a number for the double bond. This would be one of those aspects. Because what is this called? This is just propene. But if you really, really want to be specific, you would call it what propene? 1. Okay? You don't have to write the 1 for that. Okay? Just because it would just be understood that it's after the first carbon. But this is not the case. It's after the 3rd. So then this number refers to that. This says there's a methyl group. Where's it located? On the 3rd carbon. This says there's a chloral group located on the 2nd carbon. Okay? Yes? No. You want to know the answer, or it's something that you're not going to be responsible for? Yes. Yes. Mm-hmm. 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 All right. Can we erase this? Okay. At least at this time, I don't believe there's any compounds with two double bonds in that. That's more so of a. It's not that it has to be a senior level application, but let's maybe stop to where um, what we think would be relevant. Okay. We could, but at this time, we're not going to worry about that. Next color. Okay. Which I call that blue. Which, top or bottom? Okay. So here you have a name of a compound. So here's our chance to reverse engineer this. Okay. What organic family do we have? What organic family do we have? It's an alkane. So that means, is there anything other than carbon and hydrogen in here? No. It's a straight hydrocarbon, just hydrogen and carbon. Now, what's true about the bonding between all of those carbons? It's single bonded. This is what's telling you that it's an alkane. Okay? So what is this telling you? How many do we have? There's 8 of them. Okay, so we line them up. If you want to bond them together, that's fine too. Okay, 3, 6, 8. We can go ahead. So right now, we've got octane. Okay? What is that telling you? What is a methyl group? Okay? A formula of CH3. Okay? How many of them are there? There's 2 of them. And where are they located? On the second carbons. So you want to read right to left or left to right? Okay? So way over here, here's the first one. Okay? Don't do this. Why not? Correct. Because now you would have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you would have 2 methyl nonane. Okay? You would be half right. Okay? So we don't want it there. We want it on the second one. So there's a methyl group, and then you can write it either way. You'll never be wrong, well, unless you write it incorrectly, but you'll never be wrong putting the structural formula as opposed to the molecular. If you're running out of space, it's fine to use the molecular formula, but whatever you're more comfortable with, okay? So we've got our alkane. There's 8 carbons. There's 2 methyl groups, both located on the second carbon. Then, that's new. Isopropyl. Okay? So on your 4th carbon, this one, you want to go on the top or the bottom? Okay? So we're going to stretch that out a little bit. So there's a carbon. Okay? So does it go straight down? Why can't we go straight down? It's a propyl group. That should work, shouldn't it? Because propyl is different than isopropyl. Okay? So, what do we have on both sides of this? Okay? So we'll put a carbon here and a carbon here. Okay? And is that it? We're missing one thing. One more hydrogen. Right there. Okay? So C3H7 is a propyl group. There is a condensed formula you can use for this. That's more so That's how seniors would probably write this like that. Yes, you can, but it's just a lot easier to see when you do that. Okay? These, again, that would mean the same thing. Because you got two methyl groups. There's one there, and one hydrogen. That's right there. All right. So that takes care of him. So, again, we reverse engineered everything. We have everything in its place. Okay. Next. This one. Okay? So we've got 8 carbons, so that is octane. I hear 7 and I hear 8. I agree. That's correct. Okay? If you go this way, 1, 2, 3, 4, 5, 6, 7. But if you go this way, 1, 2, 3, 4, 5, 6, 7, 8. Okay? So is there anything branching off of that octane? Yes. What is it? Okay? All right. Is there any questions on that? Okay. So the last one is the simplest. But sometimes the simplest ones can be the most difficult. Didn't say it was, it just means it can. Are you sure? Okay. So one of the things, you can go 1, 2, 3, 4, 5, or you can just rather go straight across, saying 1, 2, 3, 4, 5. So we've got pentane. Okay. 2, 3. Think of where you're at right now in naming and drawing these, as opposed to 2 days ago. Have we jumped forward by leaps and bounds? Okay. Left side, are we good? Back row. Right middle. Right outside. You can say, some of you, I can say, don't smile. If you smile, you're not going to break your face. Okay? Yes.
Okay, so like if you have, we're working with like octane, and on the first carbon, there's one carbon underneath, 2 carbons up. It's just, there's that's a ethyl and a methyl.
Can.
On the same thing.
Yes. That's possible. Yep. So the simplest isomer that you could do for this is go ahead and take this guy off of the third one, put him on top of the second one. So it's easy to forget how to do isomers, but let's try not to make it that difficult. Okay, any questions? Okay, we'll catch up to you next time.